So today we're going to be naming polyatomic ions. Do you remember what polyatomic ions are? How to recognize them?
Polyatomic. Well, poly means many.
Uh-huh.
One of those, okay. And atomic, that means like atoms.
Right.
So it means many atoms.
That's right.
Okay.
Poly equals many, and atomic atoms.
And then it's polyatomic ions, so it seems like it's ions that have several atoms.
That's right. We got ions that have more than two elements, right? Normally when we've been talking about compounds, we got two elements in the binary naming. This time we have more than two. And you can recognize them when you have more than three capital letters. I have K right here, that's potassium, I've got sulfur, and I've got oxygen. So it's more than three capital letters. I have a polyatomic ion in here somewhere.
Well, so it seems like that name's going to get really long then if we have to just keep saying different elements' names.
Well, not always. We're not going to name each of, like the potassium, the sulfur, and the oxygen. It doesn't have to be super long. We can actually bunch them all together and have a name just for the polyatomic part.
Oh, so each polyatomic has a name?
Yeah, each polyatomic ion has its own name.
Okay.
And we're going to need this chart right here to find them right here. So you should have one of these reference charts in front of you. It's got a list of all the polyatomic ions and their formulas so that you can recognize them. So the first thing that we need to do is name the cation, which is this positive part that's in front.
Oh, the metal.
The metal, yeah.
Okay. So K, that's potassium.
That's right. So we're going to name potassium right here. And now we got to name the polyatomic ion, which is this part. That little guy right there is our ion. That's our anion. And we're going to look at our chart, see if we can find it. See, it was SO3.
SO3, so that's sulfite.
There we go, right there at the bottom. Sulfite, right there. So now we put the name of the ion after the cation. Potassium sulfite.
So what was with all those numbers going on the sheet? Sulfite had like numbers at the bottom and at the top.
Oh, those are the charges. So the number at the bottom, that subscript, that applies only to the oxygen. That's telling me that I've got 3 oxygen atoms in this polyatomic ion. Again, we got many atoms, polyatomic, many atoms. I happen to have 3 oxygens here. The subscript, that 3 does not apply to the sulfur. I've only got 1 sulfur.
Okay, so there's 4 atoms total, 1 sulfur and 3 oxygens.
That's right.
Okay.
But overall, this bunch of atoms together have a charge of 2 minus.
Oh, okay. -2 charge for the whole group.
For the whole group.
Okay.
So that's why there's a 2 subscript right here in front of the potassium, because potassium has a charge of +1. And this sulfite ion has a charge of -2. So if I were to crisscross these, which we'll get to in a little bit, I would need 2 atoms of potassium to balance out the -2 charge on the sulfite. But we're going to get to that here in a little bit.
Okay.
So let's name the second one. I've got a whole bunch of atoms right here, don't I?
Yeah, it seems like you have a couple of the same ones.
Yeah, it looks like I got a bunch of nitrogens here, and I've got some hydrogens, and I've got oxygen. So I have to figure out which ones of these are grouped together in the polyatomic ion, like which one's the cation and which one's the anion. If I can find it on my chart right here, then I know that it is a polyatomic ion. NH4, that was the first part of the formula, is right here.
Oh, I see.
There's ammonium. So that's my cation. That's the positive part. So I'm going to name this right here ammonium.
So you can have a polyatomic start at the beginning as well as be at the end.
Oh yeah, we can have polyatomics all over the place. Now let's see if I can find this second part. I think this right here goes is also on the chart. It is right there.
Oh, I see it.
Nitrite.
Nitrite, yeah.
So ammonium nitrite.
Well, that seems
Yeah.
pretty easy.
It is pretty simple.
Yeah.
You just got to figure where the groups are and then find them on the chart. How about this? I know what this is.
Well, that looks like we have copper at the beginning.
We do have copper.
And then since we have two more, I'm going to guess that those two are
Mhm.
a polyatomic ion.
That is the polyatomic ion right there. All right, let's see if we can find it. We got
There it is.
hydroxide.
Hydroxide right there in the middle.
All right, so now we just name it hydroxide. Copper hydroxide. But, oops, sorry, I misspelled hydroxide. This copper is a transition metal.
Oh.
Do you remember the rules for transition metal?
Well, I know that some transition metals can have multiple different types of charges.
Mm-hmm.
So we have to kind of say, hey, this is this exact charge. And I think we use Roman numerals.
We do. We still have to use our Roman numerals here. Hydroxide has a charge of -1, which we got from the chart right here. Hydroxide has a charge of -1.
Mm-hmm.
So since there aren't any subscripts right here, this means that this copper also has a charge of 1, a +1.
Oh, so the copper and the hydroxide have to have the same charge, so they cancel out.
Right, that's right. We want the whole thing to be neutral still. So this is going to be a copper 1 hydroxide.
That makes sense.
So the rules for transition metals still apply here.
Even when using polyatomics.
Yep. So we have to have compounds still must be neutral. Here you go. That's important. All right. That's pretty much it. You think you got it?
I think I got it.
All right. If you have any questions, be sure to ask your teacher.